Hello again and welcome back. Area of sector international A-level question. Figure 1 shows the design for a badge. The design consists of two congruent triangles AOC and BOC joined to a sector AOB of a circle center O. It says that angle AOB is equal to alpha, AO is equal to AB, which is equal to 3 centimeters. We can see that there. And it says given OC is equal to 5 centimeters, given that the area of sector AOB is 7.2 centimeters squared. A, show that alpha is equal to 1.6 radians. B, hence find the area of the badge, giving your answer in square centimeters to 2 sig fig. And part 2, the perimeter of the badge, giving your answer in centimeters to 1 decimal place. And in total, 10 marks. So let's get going with this. First of all, the area of sector is equal to half r squared theta. So we need to write that down. The area of sector is equal to a half r squared, and it's theta, but I'm going to replace that with alpha because that's the angle given here. So substitute that value in of 3 for the radius. So we got a half 3 squared, which is equal to 7.2 square centimeters. So that gives us 9 over 2, alpha. 9 over 2 alpha is equal to 7.2. So that gives me alpha being equal to 14.4 over 9. So alpha is equal to 1.6 radians. And that's part A done. And now part B, part 1, we need to find angle COA. Angle COA is equal to a half, I need to just erase that, a half and we got a half, that's better, a half, and we have to do 2 pi minus 1.6. That's the angle COA. And that will give me angle COA equal to 2.34 radians. And continuing on, we need to find the area of triangle. Area of triangle COA. COA. The area of triangle COA is equal to a half AB sine C. Now a half AB sine C, substituting the values, that's going to give us a half times 5 times 3, a half times 5 times 3, and the sine of 2.34. 2.34. And that will give us the value, when you go to the calculator, of 5.39. And make sure your calculator is again in radians. Now, continuing on from there, we've now found the area of triangle COA. We need to now know the total area of the badge. So the total area will be equal to, and we have two lots of 5.39s, because we've got two congruent triangles. So that will give me 2 times 5.39, and then I've got to add the area of 7.2 square centimeters, because that's the area of sector AOB. And that gives us a total of 17.96 on our calculator. And now the arc length needs to be found for part 2. Part to be the arc length is equal to r theta, or in this case r alpha, which is equal to 3 times 1.6, because the radius times alpha, which is 3 times 1.6, which is equal to 4.8. 4.8. Now, we need to use the cosine rule twice because we have two congruent triangles. So using the cosine rule, which is a squared is equal to b squared plus c squared minus 2bc cos a, and I can use ac squared because that is in fact what our triangle is equal to 2 lots. So I'm going to do this one first and then double it. So is equal to 5 squared plus 3 squared minus 2bc minus 2 times 5 times 3 times the cos of 2.34. They ran out of space there. And we can do that all on the calculator. Sorry for the mess there. So we have our calculator and we do all in one go, and we have the square root of 5 squared plus 3 squared minus 2 times 5 times 3 and the cos of 2.34, and that will give us 7.41, but we need to double that because we've got two congruent triangles, and of course we must add, and I forgot to put that in there, we must add 3 lots of 1.6, 4.8. We must add 4.8. So, and of course, I've got to add 4.8. So we need to write all of that out again because that doesn't look very clear. So let's make sure that we have 5 squared, and it's, oops, making mistakes, it's real time. 5 squared plus 3 squared minus 2 times 5 times 3 and times the cos of 2.34 and plus 4.8, and that gives you the answer on the calculator of plus 4.8. 4.8 is equal to 19.6, and we're supposed to give the answer to 1 decimal place, so 19.6 is the answer. 19.6, and that's 10 marks.